I will be performing the lab 6. Okay, so let me open the task of the lab 6 first. As you can see, the lab 6 was about the serial communication using SPI or UART, or you can say I scarce C. So over here we have the handout. So I will just move towards the tasks that we needed to perform in that lab. Oh, I remember the tasks were sent by our teacher on the WhatsApp. So I will just tell you what were the tasks. So first of all, our task was to connect an interface and LCD using UART communication. Okay, and then interface and hex keypad with it and display the value of the hex keypad on the LCD. So now actually what is UART? So let me tell you about that. Sorry for the that. Actually, UART is used for the communication, or there are two types of communication. One is serial communication, one is parallel communication. So the parallel communication is basically much faster and much reliable, and it's cheap. But the only disadvantage of the parallel communication is that it cannot be done for the long distances, and for the serial communication it can be done for the long distances, and it's cheap, but it is very slow. The rate of data transfer is really slow. So over here I'm using the UART protocol and doing the lab and displaying the values of from the hex keypad on the LCD. So let me show you the code first. So this is the code. Now in UART actually there are two. One is the master and the second is slave. So now what the master do is basically actually master takes the commands from the hex keypad and it sends that data to the slave. Now slave, you can see that the one which is the obedient of its master, and it will have to display or do whatever the master says. So now if I will press one over here, the one will go to the master, and master will send that data from txd and rxd to the slave, and slave then display that data on the lcd. So basically you can say that in UART protocol, or we used to communicate with our microcontroller, ठीक है, using master and the slave concept. Okay, and over here you can see that UART has the register, some control register, which is UBRR, UCSRA, UCSRB. These are actually the control register which are used to initialize the communication speed, data size, and parity. Now parity is basically to check that if our parity bit is high or not. It is, you can say, a type of flag which is used to perform a task. If a parity bit is 1, then perform this specific task or do this something or anything that you are performing, or if parity bit is 0, then do this and whatever you are doing in the code. Now send and receive register is UDR, and then there is a status register on which we can see everything. So now let's move towards the code. As you can see, the code is actually quite simple but it's very lengthy, so I will just give you the main idea. Okay, so over here actually I have included the libraries first. Okay, after that I have created a two-dimensional array in which I am storing these values. As you can see, these are the values of the hex keypad. As you can see over here, hex keypad 789 divided by 456, multiplication sign 123, subtraction sign 0 equal to, and addition sign. So as you can see over here, these are that, and after that I have initialized some variables. Okay, and after that I have created a function search which will be using that which button is being pressed on the hex keypad. It will search that at what row and what column number which button is being pressed, and after that I have initializes two variable to the 0 and then x. Now over here this is the function of the USART initialization. Okay, now over here I'm using the control registers. Okay, and setting the mode to the 8-bit mode of the USART protocol. Now you can see that UBR roller is used to set the bot rate. Bot is actually the communication rate through which we will be communicating with our microcontroller. And after that, I have created a function of the send data, which will be sending data to the slave after receiving the data from the hex keypad. And then this is the search function. Okay, what basically the search function do is actually it will be searching that which button is being pressed. For that, I will have to check every row and every column, and that logic is what I have written over here. That if first go and check which button is being pressed, because whenever the button will be pressed, it will be set high. So after when it will set high, okay, then we will check this condition, and then the a1, the correct the variable that initialized will be equal to the row number and the column 0. Okay, it will check the column 0 of the hex keypad and will check which number is being pressed on the row. And then it will check the next one, will check the if condition, will check the second column first row, and the third one will check third column first row. Similarly, I have write the combination of rows, and over here this is the main body of our program, over where all the task or main functions are being performed, and I'm calling all the functions. So over here I am calling the function USART initialization, which I have just explained you earlier. After that, I have set two ports, high and low, half port high and half port low. Okay, now after that, I have set a while loop which will keep on running this program forever. And then I have initialized x to equal to the value of the pin b, and check if x is equal to high, half high, then just break, come out of the loop. If it's not half high, then keep on searching which key is being pressed. This is the program which will keep on searching that which key is being processed or pressed, as I have shown you above. The function which was searching that the column 2, then row 1. Over here, when if we will press the row 3 button, then instead of r1, I have write a logic that over here it will come r3, and it will search. Look over here, r1, if the third row button is being pressed, so r1 will be equal to 3, and then it will go to the third row and will check its first column, then second and third, and so on. And over here it is the slave code of the sort protocol. Over here what I am doing is actually, you know that I have connected the LCD with the slave. So what I am doing in the code is initializing the library. Okay, this is your library set. The name I rename it as a 328p.h. Okay, now I am initializing in the main LCD. Then after that, I have set the pin 0 as an input port, and then I have declared port P as an output port. And over here what I am doing is giving a value, initializing a value to the register of the USART, setting the baud rate. Okay, and after that I am just assigning the upper bits of the UBRR and the lower bits. Okay, now after that what I'm doing is these are the control registers of the resort, as I have shown explained earlier. So I'm just enabling the transmission and the reception pins. Over here you can see these are the transmission pins, this is the reception pin. Actually these are the pins through which I will be communicating, you can say the master will be communicating through slave. Okay, so transmission pin is basically sending the data to the receiver, and it will be receiving through the reception pin. And then the slave wants to tell something, it will send the data through the transmission pin, and that will be received by the master to the reception pin. So that's what I'm doing in this program, and that's what the simple logic is. And then I have just declared a variable of the received data and simple while loop, and which is just checking that if the received data is equal to UDR0 or not, then write that data on the LCD. So I will just run the simulation of the UART so you can see that it's working. As you can see, if I will press 7, 7 gets written. If I press this, 0 gets, then 2, 3, 6, 6 minus division 9, everything is working properly. Actually, my laptop is being slow, so it's processing a little bit late. So I will just stop this simulation and move towards the SPI protocol. No changing. So this is the SPI slave code, and this is the SPI master code. So this is the protf of SPI protocol. Now let me tell you what is an SPI. So SPI is actually a type of communication in which we use the master and slave. Like there is a master, okay, it send data towards the slave, and the slave will display that data on the LCD. Okay, now there are actually four pins communication in the parallel communication is being used in the SPI. As you can see, there is SDO data output pin, then data in pin, then the serial clock pin, then the chip enable. Actually, the CE pin is the chip enable pin. If it's not high, then our chips master and slave will not be working. So you have to make sure that whenever you are using the chips you IC, you should set this enable pin high so it will work. So now the simple communication that is being used in the SPI protocol is through these pins: meso master, output slave in. Actually it, what it is that the output that master will be sending to the slave, it will be the input for the slave, and the input for the slave will be output of the slave will be the input for the master, and they will be using the TXD and RXD reception and transmission pins to do this. And SCK is the serial clock, and it is to set the SP slave, set slave SS pin. Okay, so this is the Arduino, which will be, one of which will be our master and one will be our slave. As you can see, this is our master. Okay, now it is just sending the data to the slave, and slave is receiving it and displaying it on the LCD. Sorry about that. Here are some control register which are used in SPI protocol. Okay, the status register, data register, and these are the rest theory. And now I will just show you my simulation that it's working, then I will explain you the code. As you can see, I press 7, 7 gets written, 8, 9, 4, 5, 9. Actually the mouse button is not working quite well, so I have to press it. 3, it's working. So I will stop it and now move towards the code explanation. So this is the SPI master code. So what I am doing in it is actually, I will tell you that simi it's same as the UART. You can say that all I am doing is just I have to define just the master output slave input and the master input slave output and the slaves or set slave pins, so through which I will be controlling all the communication through the slave. So that's why I have to define these pins, and the rest of the code is same as the UART. The same logic is being used. It will check that which button is being pressed on the column and then display its value on the LCD. Okay, the rest of the code is actually quite same. There is no changing. The same logic is used. All you have to do is just to change the function. Like in USART or UART, we were just using serial communication or parallel communication, but over here in SPI actually the communication is done through master and slave. Okay, so that's why we have to do is just to have a little bit concept of it, and then we will be able to perform it. Same as over here, I'm just initializing the LCD and just displaying the value on the LCD after checking that what is the value on the SPSR. Over here it is a comparing value which will check that which, if our flag is high or not. If it's high, then it will display it on the value. If it is receiving some value, it will display it on the LCD using the LCD data write command, as I have shown you. So I will just move towards the lab 7 now. So our lab 7 was about external interrupts. I will open the Proteus, then let's open its code. So here is the code of the external interrupt. Well, first, let me explain the code. I am just including the library of the interrupt, then the delay library, input output library of the AVR, and the LCD library that was given by you, sir. I can show that to you. Okay, over here, as you can see, this is your library LCD, CMD, and so on. So I will just explain the code. So first time what I'm doing is just setting the port D, B, C. B and C port are set as an output port and port D is an input port. Now I'm just initial calling the function of the LCD to initialize the LCD. It will turn on the LCD, and now what I am doing is that on port B, I am just setting pin 2 and pin 3 as an input port, which will pull up the enable of the LCD. Then over here it is EICR is basically a triggering register which is used to change the logic in the interrupt, and EMSIK is used to set the interrupts as high or is used to enable the interrupts. Okay, and SEI is a global variable to turn on the interrupts. Okay, after that I'm just using the while loop which will keep on running it forever and just displaying the data, and over here I'm shifting the data 10 times towards the right because you have told us to make a function in the library that will shift your data on the right and on the left if you will give something to it. And over here it's just basically just initializing the interrupt 0 and just displaying its value. First I'm clearing the LCD, then displaying the interrupt 0, and when I will press the button, okay, one button for the interrupt 0, it will show interrupt 0 on it, and if I will press the button number 2, it will display interrupt 1 is being used. So similarly, actually over here these are the mode of which are setting our interrupts. It is initializing our interrupt 0 and this is initializing our interrupt 1. Okay, EMSIK, it will enable our interrupt 1 while I will press the button 2, and if I press the button 1 it will turn on my interrupt 2. So EICR is basically a register which is telling that when or which pull up communication or the half upper edge or the lower edge communication is used to communicate these interrupts. So over here I am just using 80 mega 2560, and I will just simulate it. So now as you can see, left 7 it will move towards right and then left. Now these are the two buttons. As you can see, the one is used to enable interrupt 1, one is used to enable interrupt 0. As you can see, if I press this button, the interrupt 0 is being enabled. Now if I press the other button, okay, enable interrupt 1 will be enabled. Okay, let's stop and play it again. As you can see, if I press this button, the interrupt 1 is being initialized. Okay, if I press this one, interrupt 0 is being initialized. So was our lab 7, and I did perform it well. I hope you were able to understand. If you have any question or queries, you can tell it